Hello everyone. Today in the subject of industrial biotechnology, we are going to study about the ethical issues against molecular technology. So the main objective of this lecture is that to give you a brief introduction to the bioethical issues linked with molecular biology, and outcomes will be that we will be able to understand the fundamental applications of this particular topic that are employed in different aspects of bioethics. So, coming on to the introduction, bioethics is a discipline of applied ethics and comprises three main subdisciplines like medical ethics, animal ethics, and environmental ethics. So, these are some particular aspects of the topic named as bioethics. So, when we are talking about bioethics, ethics are morally correct things, and bioethics are the two terms that are combined like all together, like biology and ethics. So, when it comes to the medical field, also as bioethics, and when we are dealing with the experimentation with the animals, animal ethics comes comes into the role play, and when environment is engaged with the overall scenario, then environmental ethics also comes into the spotlight. So even though they are distinct branches in focusing on the different areas, namely human beings, animals, and nature, they have a significant overlap and particular issues, vital conceptions and theory, as well as prominent lines of argumentation. Solving bioethical issues is a complex and demanding task. So, what are the important things that are required to solve such issues? Policy, dignity, technology. Okay, you have to look into the matter with the intrinsic detail. And bioethicists are the individuals who are responsible to strike a perfect balance in between the public and the bureaucrats, and on the other hand, the scientists. So, public science, human ethics. So, bioethics or the individuals who are known as bioethicists are the people who are there to deal with the scientists and with the bureaucrats on the other hand in order to balance the scenario and balance the situation in a particular manner. An interesting analogy in this case is that of a neural network in which the neural knot can be compared to the bioethical problems. So, whatever the problem of bioethics is there, there has to be a solution. And every time the whole communities of scientists and bioethicists are working to find a solution all together. And the network itself can be compared to many different links to other vital issues and moral problems on different levels and regarding different disciplines and subdisciplines. Sometimes it seems that the attempt to settle a moral problem stirs up a honestness because many plausible suggestions cause further serious issues. So, what is the main scenario? Like a scientist or the scientific community who are engaged in the research work, they are mostly engaged with their work. Okay, and they are the individuals who do not care about anything else, right? They are much more indulged into their research and other things. But the main problem arises when the public is concerned about the research that is going on, right? And the main problem arises when bioethicists they start to discuss the problems on behalf of bureaucrats with the scientists. So sometimes, in order to find a solution, it stirs up the hornet's nest because a lot of problem they start to arise when a problem is tried to be solved by the individuals. So one must understand the sensitive scenarios that are linked with bioethics, okay, and especially with the molecular biology, right? It has started to stir up a lot of discussion that are linked with humans, humanity, religion, and all other things. So people have started stating that okay, this science is ungodly, and sometimes they say it's blasphemy. So we have to deal the condition in the correct scenario so that there is no problem and it can readily be dealt with without any issues that is linked with any ethics or medical or justice or confidentiality, autonomy, dignity, moral, okay, and we have to see that traditionality is maintained, okay, and every party is patient, and we are working all together for the healthcare and all other things. So typically we have to see into the matter with a lot more maturity and not leaving any of the party uh, unhindered or unnoticed. So we have to practice justice and confidentiality also. So this is how the molecular biology is significantly a new topic of discussion when it comes to bioethics. Biotechnology comprises on various techniques that exploit the application of biological organisms, systems, or processes for the benefit of human beings. So, if we start the topic from the very early beginning, we know that what is the correct meaning of biotechnology. In the long term, we can understand that biotechnology is the use of biology combined with technology for the benefit of humans. Okay, but sometimes it is exploiting the organisms and sometimes the system that processes the benefits for human beings. So whatever the things are there, they are readily being used for the benefits of human beings. It has helped the medical science by developing new diagnostic tools and kits to diagnose the disease. Okay, so new diagnostic tools are being developed, new kits are being diagnosed to diagnose the disease. So everywhere the efforts are going on. Like in COVID situation, you can see the new test kits are being evolved day by day. Industrially, it has created a thriving business in enzymes, uh, antibody, and promises newer and less expensive products. So, in the long term, every time you see the developments are going on, so it requires a lot of research on living organisms in order to promote less expensive products in order to develop the products that are less expensive. Biotechnology has improved the agriculture production by developing variety of varieties having resistance against biotech and abiotic stresses. So, biotechnology has also introduced a green revolution when it comes to the implementation of molecular biology. Okay, the crop breeds have been readily improved, the disease resistance have been improved, and plants are now um, can tolerate the abiotic stress, the disease attacks, and water scarcity much more in a very effective manner. So, biotechnology is also uh, altering the scenario of agriculture, and the scientists are constantly trying to improve the varieties and breeds. Production of disease-free plants with improved nutritional value has proven the role of biotechnology in agriculture sector, right? So, a production of disease-free plants is also a very important case that also carries improved nutritional value. Like golden rice was a perfect example of that. So, biotechnology has also influenced a lot when it comes to the role of agriculture sector. These biotechnological techniques also have been criticized by various religious scholars, scientists, and economists. So, on the other hand, biotechnology is doing miracles that were not expected in the last century, but it has transformed itself completely. But it is also facing it is a double-edged sword, and they are also facing uh, criticism from religious scholars, some scientists also, and some economists also. Present review has elaborated the various techniques and their related ethical, social, and economical factors so that we may know about the possible benefits and related risk before using applying these techniques in any field of biotechnology. So there is a ethical stigma that is linked with molecular biology. There is social stigma that is linked with molecular biology, and some of the economical factors also. But also on the other hand, there are many benefits that we can reap out of this implementation of this technology. Related risk before applying and using any field or of the biotechnology. So, what is the main scenario that is lacking? The things that are lacking are proper education to the people and to the communities of who are serving as intellectuals and experts. If they are educated in a proper manner and if they are made to understand the working scenarios and working procedures and they are exposed to them, then it is better to make them understand what are the correct things that can be beneficial with the application of molecular biology or biotechnology in the face of uh, improvement of crops, improvement of animal breeds, and a variety of products. So, when it comes to the criticism, it can be dealt in a very positive manner, but it does require a lot of patience. It does require a lot of clarification. It does require a lot of education that is essentially required by the people who do not have a scientific background. Utilitarian, utilitarianism. One of the most prominent and influential ways of ethical reasoning and decision making in the field of bioethics is based on utilitarianism. In the late 20th century, utilitarian approaches were so influenced that many people outside the academia believed that all bioethicists were utilitarianism. Like they are trying to utilize the things and for their own benefit. Utilitarianism, in fact, contains a wide range of different approaches, but one of the but one can distinguish four important core elements that all utilitarian approaches have in common. They are consequence principle. And what is that? The consequence of a given action are the measures of its moral quality. Right. The second, the utility principle. The moral rightness and wrongness of actions are determined by the greatest possible utility for the greatest possible number of uh, sentient beings. The hedonistic principle. The consequences of a given action are evaluated with reference to a particular value. So, This particular prime value can be as follows: promoting pleasure, avoiding pain, satisfaction of interest or considered preference, satisfaction of some objective criteria of well being, and so forth. Universal principle maximizing the total utility of all sentient beings affected. So, the progress of science in 20th and 21st century ex- exploded, creating technologies that reshaped society and extended lives. The pace of change was so great. It took society years to start asking questions about the ethics and morality of new developments. So, since the day when DNA was discovered, the molecular biology has developed a lot. Okay, we have created artificial insulin also. We have created uh, genetically modified organisms. We have created genetically modified food also, and a lot has changed. And it was all these molecular medicines and molecular technology were helping people a lot, and the change was so rapid that the whole scenario was not questioned by the public. It was so overwhelming that people were not currently, or people were not immediately uh, able to ask questions about the scenario that were going on. It was the development was so fast, and the employment of the techniques was reaping many benefits for the human being. So, in the long term, it has significantly affected, and it has had significantly developed new scenarios, new arenas of discussion, and implementation of ethics, of morality to them. Now, humanity is at major crossroads where further investment in biotechnologies could change the way humans live and reproduce. So, everything is changing now. With the implementation of molecular biology, we have clearly read our human genome. We know 25,000 genes are required to make a human being. Okay, what genes functions like what thing, and what are the essential uh, information that is required to predict somebody's health in what future scenario that individual particularly will suffer from what disease. Okay, and our reproduction technology has changed. Now we are proceeding towards the artificial um, insemination technology, or IEVF. So artificial reproductive technology is also emerging. So somewhat we are uh, on the verge of deciding to create what type of humans. So, uh, for us, for the people who are dealing with the technology, it is a giant leap forward. But when it comes to the society or the bioethicist or the individuals who are not trained professionally in these sciences, it is a shock. Okay, they are not able to understand these things properly, and most of the time they start to oppose these things without having the basic knowledge of understanding. However, the advancement may come into steep a price. So advancement are also very crucial when these technologies come into role play. In 2016, biotechnology engineers and researchers uh, addressed five core concerns that are foundations of bioethics. So they also started discussing with the things with general public. So use of genetics. The Human Genome Project generated billions of dollars in funding in the 20th century. with the goal of creating a single depository of DNA based pairs and possible human genome. So, this is our greatest achievement in the 20th century after landing on the moon. So, we are now completely able to read the number of genes that are required to make a human being. On April 14, 2003, the project reached completion, and the genetic engineering field grew quickly. So, in 2003, the major change happened. Okay, everything was pulled upside down. Now we can read the genome of every human being. Okay, and what are the number of genes they have, and why they are different from another human being. Everything was open like a book. You can read the pages because we have decoded the human genome. Okay, the mystery thing that was not known earlier. Uncovering the human genome was a tremendous step forward for science, but the discovery created a series of new concerns. Okay, it was a giant step forward. It was compared to the landing on the moon, but it also opened up new phase of discussion among the scientists and bioethicists and general public altogether. Researchers have been able to use the information for human of the human from Human Genome Project to develop the new science of pharmacogenetics, the study of how an individual's genes affect his or her ability to metabolize or to react towards a drug. So now scientists were able to understand that how some individuals respond to a drug, and how some what is the reason behind some individuals don't respond so well towards a drug. So pharmacogenetics was a new field that was opened as a result of Human Genome Project, and all the information that was made public for the scenarios. The study of pharmacogenetics or the study of pharmacogenetics aims to eliminate adverse drug events (ADE) or the side effects of the drug, and side effects by tailoring drug drugs specific to the patient's genome. So what they are trying to do, they are trying to make molecular medicine a reality. Okay, while the new personalized medication can eliminate side effects, the use of genetic information to create medicine contributes to the rising cost of drugs and shifts attention away from designing affordable drugs available for mass production. So, uh, it is having both pros and cons. Firstly, it will this field of study will totally eliminate the side effects of the drug, and with the utilization of genetic information to create medicines, it will contribute to the raising cost of the drug and shift attention away from designing affordable drugs to the available that are available for mass production. So eventually, in the long term, in the long run, these kind of medications they will be uh, that have developed with the implementation of molecular biology. In the long term, these medicines are custom made. Okay, they are specifically tailored to the requirement of that very individual. They cannot be mass produced, and as a result, they are very expensive and costly. The creation of designer babies is another critical bioethical issue for geneticists. So, when you are talking about designer babies, when you are talking about gene selection, so there would be in the near future there will be two types of humans. One type will be their genes are selected, they are genetically modified, they are advanced in every sense, and each and every character they have has been chosen. And on the other hand, the people who could not afford the advances in molecular biology, they remain normal as we are nowadays, and so there will be a great rift in between the two variety of human beings. Designer babies are children enhanced through gene manipulation to meet certain mental, physical, and emotional demands of parents. So, what are the demands of the parents? They can certainly choose the genes of their children. Okay, and not only genes that are linked with mental and intelligence status, but also physical and emotional demands when it comes to the genotype and when it comes to the phenotype. So parents can readily manipulate the genes of the babies. The technology does not yet exist to manipulate the entire genome of of a fetus, but research continues along this path. So still the process is going on. Although the idea is there and idea is not being met with very good feedback from bioethicists and general public, but the research is still going on. Stem cells. Stem cells are the core of biotechnological research, right? So first of all, stem cells are the cells that are present at various sites of the body, and they can readily be transformed into a variety of cells. Okay, they are constantly growing, and you can give them a condition of a particular type of cell, and they will develop into that very cell because the stem cell lines can grow into any human tissue. They are invaluable for research into medicines and medical treatments without putting people at risk. Eventually, scientists believe that stem cells may be used to grow new organs and reverse paralysis. Almost all stem cells are the result of embryo fertilized in vitro and placed in a frozen storage. So, what they do, they fertilize an egg with a sperm, and embryo develops, and when it reaches to 32 cell stage or blastocyst stage, it is frozen, and cells inside the embryo is taken out for the research. Couples choose to use the embryos for implantation, through only a fraction of embryos are ever implanted. So that when the couples are using IVF methods, not all embryos are implanted. Okay, only the embryos that are best and in good health are implanted. So, as the cost of storage grows, couples must decide to destroy the embryo or donate them. So, when people are working like that and they are selecting the features, because the storage of these embryos in liquid nitrogen is a costly process and it requires a lot of money. So, the use of stem cells, especially in the United States, is one of the most controversial issues in biotechnology. Supporters argue the embryos used to generate stem cells, cell lines, were going to be destroyed, and using them for research has uh, the capacity to save untold numbers of lives. That is somewhat true. When you have cells that can be transformed in any kind of human tissue, it can it does save a lot of lives because when the individuals are in trouble, these cells can be injected and they can proliferate and develop new tissues and save the life of an individual. Opponents believe creating new lines from embryonic stem cells uh, is akin to abortion, and the destruction of any embryo for research purpose is an ethical violation. So, ethicists are also uh, opposing the idea of taking out stem cells from the human embryo or the blastocyst stage. Both sides have common to a partial agreement on the use of adult stem cells over embryonic stem cells. So they are saying that why don't you use adult stem cells when the same work can be performed on them? So stop using human embryos for research. But the adult cells offer far fewer options and less promising research. So when the ethical issues are presented, so adult stem cells they don't have that much regeneration capacity. They are not that much advanced already. So in the long run, they don't offer a lot of good researching options. Human testing. As medical and biotechnology grows, so do the pressure for companies to bring new products to the market. And it is somewhat true. The FDA's new drug pipeline is clogged with thousands of drugs making their way towards approval. Though only about 12% will ever see mass production. So many of the drugs people are working constantly and trying to develop new drugs, but only 12% will pass through the whole scenario of testing and research that will lead to the mass production. The approval process can take up to 10 years, and the financial stress for seeking approval is too much for many companies. One of the biggest problem with the FDA approval is the process. Is the amount of time that drug must spend in human clinical trials. So FDA has set up a particular time span that this drug is fit for the human use. Estimates show that a drug can spend as long as 7 years in human trial. Even when the drug completes the trials, it may not receive FDA approval after 7 years of testing. The pharmaceutical companies are calling on FDA to speed up the clinical trials portion uh, of the approval process, greatly reducing the time spent in the drug pipeline and increasing the profits to be made. Reducing the approval time is double-edged sword. Medications that work will begin helping patients much sooner, but rushing through the process removes safeguards put in place to keep the public safe. So, coming on to the GMO food, the most controversial topic of molecular biology implementation. A growing global population concerns about diminishing drinking water reserve and a need to keep food affordable all promoted biotechnology engineers to expand the availability of genetically modified organisms or GMOs in the food supply. So, what scientists did, they took some genes and they selected the best genes and they uh, inculcated inculcated those genes into variety that increase the production and size of the crop. The GMO are cheaper to produce and hard, heartier than unmodified food, allowing farmers to meet global food needs and maintain profits. The backlash against GMO has been strong and grows every day. Opponents of GMO or genetically modified uh, foods claim that organisms actually put the entire food supply at risk through the homogenization of plant life and the death of biodiversity. So people are saying that this practice of GMO food is not at all good for biodiversity, and we are disturbing the scenarios that are already present in nature, and we should not play God. But the experts in molecular biology say if we don't play God, then who else will? So they are constantly trying to improve the variety and improve the agriculture production procedures, and they have also introduced some seed termination technology and seed improvement technology. So every time they are also constantly working. They also argue that insects and plant destroying bacteria or disease will continue to evolve with the GM. But people also say that you are going to improve every scenario and everything. But simultaneously, the disease, plant diseases and bacterial diseases will also evolve with the evidence of uh, genetically modified food and crops. Okay, so resulting in super pests and super diseases that are untreatable by modern methods. So they will say, people are saying that if you keep on continuing these procedures, these scenarios, they will generate more and more complex pathogens and very much lethal and complex diseases that cannot be treated with the help of modern methods and modern technology. So molecular methods are somewhat they are being disregarded without understanding or in the common scenario, and proper education is needed. Finally, doctors argue that GMOs include antibiotics that make their way into the human body. Overconsumption of antibiotics is harmful because those drugs lose their ability to fight off disease. Costs. Developments in new drugs, instruments that improve the quality of life and extend life expectancy to new highs are all lofty goals, but they come at a significant price. The cost of healthcare in the United States is uh, continuously growing, and even in developing countries also it is growing, largely because innovative medical treatment, and drug options. Every year, more families go bankrupt trying to pay for treatments made available through biotechnology, and there seems to be a little signs for lower prices in future. So, the cost of medical facilities is increasing, even here in India also. The newest designer drugs will cost patients tens of thousands, if not hundreds of thousands of dollars a year. Biotechnology engineers and companies must find a way to address cost issues and make a new advancement more affordable for the average consumer. Otherwise, biotechnology will create two-tiered society that we have already discussed earlier also. Those who can afford the medical treatment needed to live, and those who cannot. So, the main issue that is arising with the application of molecular biology is that the most of the techniques and treatments that they offer are largely very expensive, and it cannot be afforded by the normal people. Legal implications of these issues. Ethical concerns of biotechnology engineering have a broad impact influencing a number of uh, differing careers and industries. For example, moving forward, it will be essential for entrepreneurs and biotechnology companies understand the ethical and legal implications within this field so that they make well-educated decisions while still remaining innovative. The health and pharmaceutical industries are so influenced by these concerns, particularly in regard to GMO foods and human testing. Individuals and companies within these industries will greatly benefit from understanding the potential legal implications of their decisions, as one wrong decision could result in the series of expensive lawsuits. Ethics in biotechnology will always be a hot button issue, and one one the industry must take the time to discuss. So every time, what is clearly regarded as essential thing is that when it comes to legal implications, that not everyone is very much supportive and very much welcoming to the molecular biology or biotechnology and the techniques and the research they do and the new technology they introduce. So uh, these things must be discussed properly by the lawsuits and all other things. Failure to do so may result uh, in the defunding of critical projects and social backlash against important research. So somewhere we are also dealing with the lack of education. We have to make people educated about the research of molecular biology and biotechnology, so that these two fields they do not face any of the backlash from the people. So scientists they have to work in this direction also. Healthcare. In healthcare, genetic testing presents several ethical challenges. Legislation is the place or is being developed to limit access to genetic information so that employers or insurers cannot discriminate against individuals because of their genotypes. Okay, so what is happening that uh, the health insurance people they are just ensuring the health of the people who are already having a very good genetic conditions. The testing for a genetic disease presents a complication not seen in other types of illness because the diagnosis of one individual immediately reveals the risk that other family members may be affected based on the rules of inheritance. For example, a young woman learned that she is a carrier of Viscott's Eldridge syndrome, which causes severe immune deficiency that is lethal in childhood. Because the mutant gene is carried on the X chromosome, each of her sons faces a 50-50% chances of inheriting the illness. Knowing that the same would be true for other carriers in her family, the young woman chose to inform all her relatives who might also carry the genes. The decision of whether or not to be tested rests with the individuals. So, the level of education is essentially very important to make the people aware of these things. New challenges. Another objection of biotechnology and molecular biology is the interference with nature, but so do traditional agriculture and medicine. However, the changes that biotechnology can introduce are usually quite unlikely to occur naturally, such as tobacco plant that glows thanks to a firefly protein on cloning a human. We place limits on some biotechnologies, but not on others, based on our uh, perception and on the intents of the interventions. The glowing tobacco plant was done as an experiment to see if a plant could express a gene from an animal. But many countries ban human cloning because it is seen as unnecessary, dangerous, and unethical. Still, time can change minds. When Louis Joy Brown, the first baby conceived using in vitro fertilization, was born in 1980, objection to test tube baby technology was loud. The procedure is now routine. In general, it seems that a biotechnology will eventually be considered ethical if evidence accumulates demonstrating that it does no harm. A biotechnology that is, by very definition, causes harm is bioterrorism, especially when genetic manipulation is used to augment the killing power of a naturally occurring pathogen. Bioterrorism dates back to the Middle Ages. when warriors hurled plague-ridden corpses over city walls to kill the inhabitants. The British used a similar approach in 18th century when intentionally gave Native Americans blankets that carried smallpox virus. Efforts in the former Soviet Union to create bioweapons from the 1970s until 1990s introduced genetic modifications. For example, they engineered plague bacteria to be resistant to 16 different antibiotic drugs and to produce a toxin that adds paralysis to the list of its effect. International efforts to ban bioweapon development in the wake of the attack on World Trade Center in New York City on September 11, 2001 might put an end to subversion of biotechnology. So, coming on to the religious issues, scientists and technologists are able to play real games with God and nature, manipulating the building blocks of living things at will. It is dangerous game. It purported anticipated benefits, notwithstanding, in which they being encouraged, aided, and abetted, supported and funded by powerful industries and corporations for motives of profit. The newly developed molecular techniques of gene identification, genetic engineering, and artificial reproductive procedures represent a quantum leap in our ability to manipulate life itself, a domain long held by culture and religion to be the province of a divine agency. Religious scholars have criticized the use of biological techniques to expose the privacy and dignity of human beings. Some religions have taken the issue of stem cell technology very serious, as according to them, research on embryonic stem cells is likely to kill the humans. Similarly, criticism of religious scholars on the Human Genome Project was very severe. It is often argued by religious people that biotechnological interventions are not natural or that they go against some divine or natural order of things. But human beings are also natural products of evolution. Our technological development is no less natural than the mud wasp construction of a nest. Thus, it must be concluded that genetic engineering is a natural phenomenon akin to genetic engineering that takes place in nature every time a gene crosses over on chromosome. A gene mutates or a bacteria plasmid migrates from one species to another. There is an important difference between natural evolutionary process and natural genetic engineering. Natural evolutionary process do not make a choice. They do not deliberate with interventions of God. Interventions of achieving an end. What distinguishes natural evolutionary process is that they are not goal directed, whereas human actions are always goal directed. To argue that genetic engineering is simply an extension of natural evolutionary process does not morally justify the practice. With this line of reasoning, any biotechnological intervention could be justified as simple, simply a natural process, but clearly not very interventions is good. Interventions is good. It is only to be determined to be good based on upon a moral deliberation that takes into account its risks and benefits, and the appropriateness of intervening in the first place. So the conclusion is that the general perception in India as of today is that out of all modern biology based technologies, the one that have the widest ethical implications are the new reproductive technology and genetic engineering, both of which, as it turns out, to have somewhat related. In the case of genetic engineering, the ethical dilemmas concern primarily the release of genetically modified organisms. These dilemmas are universal. In case of assisted reproductive techniques, the ethical questions have considerable local and cultural overtones. This article and this lecture has given several examples, such as local and cultural factors in respect to assisted reproductive techniques. So, what we are trying to do here is to make these things much more valuable and much more applicable. So, here are the questions MCQs. GEC stands for Genetic Engineering Approval Committee. Dash is right granted by a government to an inventor to prevent others from the commercial use of his invention. That is D patents. The patents granted for biological entities and products derived from them are called C biopatents. Dash includes rules of conduct that may be used to regulate our activities concerning the biological world. That is bioethics. GAC makes decisions regarding the validity and safety of organisms. That is A genetically modified. Which committee has been sent to keep check on GM research and GM product? The correct answer is B, GEAC. Various measures taken to prevent any risk to normal organisms from transgenic organisms are known as a biosafety. GEAC is set up by Dash government, Indian government. These are the references from where we have collected the material, and thank you very much for listening to my lecture.